At some point today, or sometime this week, your body is going to do something completely ridiculous. Without warning, without cause, without your permission, your diaphragm is going to contract violently, suck air into your lungs, and then a flap of tissue at the top of your throat is going to slam shut and produce a sound that has made humans look undignified for as long as humans have existed. It will happen again a few seconds later, and again, and there is almost nothing you can do about it. You will try holding your breath. You will try drinking water upside down. Someone will probably try to scare you. None of it will reliably work, and at some point, the hiccups will simply stop on their own for reasons that are only slightly better understood than why they started. The hiccup is one of the most studied and least understood reflexes in the human body, and the answer to why we get them at all reaches back not just to ancient humans, but to something far older, something that swam in shallow water hundreds of millions of years before the first human being stood upright. The real origin of the hiccup is not what you would expect, and it reveals something about your body that is genuinely difficult to fully process. Let's start with the mechanism, because understanding what a hiccup actually is changes everything about where it came from. The hiccup is produced by a sudden involuntary contraction of the diaphragm, the dome-shaped muscle beneath your lungs that drives breathing. When the diaphragm contracts unexpectedly, it pulls air rapidly into the lungs. Simultaneously, the glottis, the opening between your vocal cords at the top of the airway, snaps shut. The incoming air hits the closed glottis and produces the characteristic sound. The entire sequence takes less than 35 milliseconds. The medical term is singultus, from the Latin for a sob or gasp, and it is controlled by the phrenic nerve, which runs from the brainstem down through the chest to the diaphragm. The reflex has its own dedicated neural arc. It is not a mistake in the respiratory system. It is a distinct, organized reflex with its own trigger pathway, its own motor response, and its own sound-producing conclusion. The body did not accidentally develop hiccups. It developed them deliberately, which means at some point in evolutionary history, this reflex did something useful. The question is what? For most of the history of medicine, the hiccup was treated as a nuisance with no clear function. Various triggers were identified: eating too quickly, swallowing air, sudden temperature changes, alcohol, excitement, but no consistent functional explanation emerged. It was easy to catalog what caused hiccups. It was much harder to explain why the reflex existed at all. Then, in 2003, physiologist Neil Shubin and a team of researchers, including Christian Strausser, began developing what became the most compelling evolutionary explanation for the human hiccup. Shubin, who later became famous for co-discovering Tiktaalik, the transitional fossil-linking fish to land-dwelling vertebrates, noticed something that had been sitting in the comparative anatomy literature for decades without being fully connected to hiccup research. The hiccup reflex in humans is structurally almost identical to a breathing behavior found in modern amphibians, specifically in tadpoles and in the larvae of certain fish. Tadpoles, which have both gills and primitive lungs during early development, use a specific motor pattern to drive water over their gills while simultaneously preventing water from entering their lungs. They contract the muscles that draw water in, and then they snap their glottis shut to stop the water going further. The neural pattern for this gill ventilation behavior, when mapped against the neural pattern for the human hiccup, shows a striking structural similarity. The same brainstem circuits, the same sequencing of muscle contractions, the same glottal closure at the end. Shubin's argument, developed further by evolutionary biologist Callum Ross at the University of Chicago and neurologist Joseph Abuckmail in subsequent research, is that the human hiccup is a retained ancestral reflex, a piece of neural machinery that evolved hundreds of millions of years ago to drive gill ventilation in aquatic ancestors and has persisted through every evolutionary transition since, through the fish that first crawled onto land, through the early amphibians, through the reptiles, through the mammals, and into the body you are using right now. The reflex no longer serves its original function. You do not have gills. You have no need to pump water over respiratory organs while blocking your airway. But the neural circuit that once drove that behavior is still embedded in your brainstem, and under certain conditions, it still fires. This places the hiccup in the same category as goosebumps and the palmaris longus muscle, vestigial remnants of functional systems that have outlasted the contexts in which they were adaptive. But there is a significant difference. Goosebumps involve a simple muscle contraction with minimal neurological complexity. The hiccup involves a dedicated, multi-component reflex arc with its own trigger pathway pathway, its own timing, and its own acoustic signature. It is not a simple leftover. It is an entire retained behavior running on neural hardware that is hundreds of millions of years old inside a body that has no use for it. Physician and researcher Daniel Howes at Queen's University in Canada has spent years studying pathological hiccups, cases where the reflex fails to stop and persists for hours, days, or in extreme cases, years. The longest documented case of chronic hiccups belongs to an American farmer named Charles Osborne, who began hiccuping in 1922 and did not stop until 1990, a total of 68 years, during which he hiccuped an estimated 430 million times. Osborne lived a largely normal life, married twice, and raised children. His hiccups only stopped a year before his death. Howes and his colleagues have identified that chronic hiccups are associated with disruption to the same brainstem circuits involved in the reflex, confirming that the hiccup does indeed have a specific neural home in the most ancient part of the human brain. The brainstem is the oldest part of your brain in evolutionary terms. It governs breathing, heart rate, swallowing, and the most basic autonomic functions. It is the part of the neural architecture that is most conserved across vertebrate species, most similar between a human and a fish. The fact that the hiccup reflex lives there rather than in the more recently evolved cortical structures is consistent with it being genuinely ancient, a feature of neural organization that predates the development of the structures responsible for conscious thought by hundreds of millions of years. Here is the part that changes how you think about your own body. You are not simply a modern human organism. You are a modern human organism built on top of an ancient aquatic one, and the layers have not been cleanly separated. When you feel your diaphragm contract involuntarily and your glottis snap shut, you are experiencing the firing of a reflex that your fishy ancestors used to breathe underwater. Your body is running software that is hundreds of millions of years old on hardware that has been updated countless times since, and occasionally the old code runs when it has no reason to. This is true of more than just hiccups. Your embryonic development briefly produces structures resembling gill slits before they are reabsorbed and repurposed into parts of your jaw, your inner ear, and your throat. The nerve that controls your larynx, the recurrent laryngeal nerve, travels all the way down into your chest and loops around your aorta before coming back up to the larynx, a detour that makes no anatomical sense in a human body but makes perfect sense as a preserved arrangement from ancestors in whom the nerve and the artery it loops around were positioned much closer together. Evolution does not redesign. It modifies. It adds. It repurposes. And sometimes it simply leaves things running that no longer need to run. The hiccup is a small thing, an inconvenience, something that makes you look slightly ridiculous at a dinner table, but it is also a direct signal from your evolutionary past, a reflex that once helped a gill-breathing ancestor survive, preserved across 500 million years of anatomical change, still occasionally misfiring in the body of a species that has been to the moon and mapped its own genome. The next time your diaphragm contracts without warning, you are not malfunctioning. You are, briefly, running on very old code. Code that worked perfectly once, in a world you can barely imagine, for a body that no longer exists.